El Instituto de Investigaciones en Matemáticas Aplicadas y en Sistemas les da una cordial bienvenida al primer coloquio del Centro Virtual de Computación 2018. Para comenzar con este evento, nos congratulamos en presentar la ponencia magistral Reinventing Businesses with New Technologies, reinventando los negocios con nuevas tecnologías. Para brindar esta ponencia, nos hace el honor de acompañarnos el Dr. Farroq Azam, Principal Data Scientist en SAP Américas. Recordemos que SAP es una de las empresas de ERP con más renombre a nivel internacional. Antes de comenzar, brindaré una breve reseña sobre nuestro ponente. Dr. Farroq Azam tiene un doctorado en los campos de la ingeniería eléctrica y la ingeniería en computación, con énfasis en Machine Learning y técnicas de optimización. Tiene 20 años de experiencia combinada en el campo de la academia y la industria. Ha publicado artículos de investigación en el área de Machine Learning y sus subdominios. Su principal área de expertise es en la aplicación de modelación de datos analíticos en los negocios, a través de técnicas estadísticas convencionales y aprendizaje máquina. Farroq Azam es un miembro senior del Instituto de Ingenieros Eléctricos y Electrónicos IEEE Computer Society, IEEE Computational Intelligence Society y la IEEE Systems Man and Cybernetic Society. Cuenta con la patente Computerized System and Method for Estimating Levels of Obesity in an Insured Population. Sin más que agregar, recibámoslo con una cálida bienvenida.
Thank you so very much, Victor. Good morning, everyone. My name is Farroq Azam, just like Victor mentioned. The only thing which I would like to point out is one of my colleagues who was supposed to be presenting, and he speaks Spanish, and you can see I do not. But unfortunately, he fell sick in the morning, so I will be filling in his place and will try to do my best to explain the concept which he wanted to do. So, in this presentation, it will be kind of unlike an academic presentation in which our conference papers in which we have lots of mathematics, some kind of a graphs, some conclusions, some next steps or next actions. This is just a presentation to give a flavor of machine learning and artificial intelligence techniques, how they are being used in the industry. And I, being an employee of SAP, I will present what SAP's point of view is for the artificial intelligence applications, as well as how to utilize big data along with the machine learning technologies to deliver solution to the problems that customers are facing, or in general, the industry is facing. To start the discussion, what we think of machine learning at SAP. Machine learning at SAP involves three broader categories. The top level category of the machine learning and artificial intelligence technology are the embedded products, in which we have the machine learning algorithms dedicated for specific applications, artificial intelligence techniques dedicated for specific use and application. Models have been developed, optimized, and embedded in the applications themselves. One of the examples, for example, to draw the analogy, what I'm referring to in here is like Google Maps is an embedded application of big data and machine learning. Whenever we try to find a route from point A to B, it gives us a very optimal route. That's the embedded application, and we have a set of application at SAP that solve certain customer engagement forecasting, demand forecasting, and those kind of solutions. The bottom layer of the technologies that SAP has to offer are the technologies for expert data scientists, the persons who have the degrees like masters or PhDs in artificial intelligence, machine learning. They know which algorithm is suitable for which situation. For example, if we are trying to develop a forecasting model for a slow-moving item, the Carsten algorithm is the best for forecasting those kind of situations. If we have a fairly regularly patterned time series to forecast, maybe ARIMA, exponential smoothing, those kind of algorithms may be better. So the person who is utilizing the bottom half of the technologies for big data, they need to know what they are trying to accomplish and what are the appropriate algorithms to accomplish that task. But most of the folks in industry, they do not have advanced degrees in machine learning, statistical domain, or artificial intelligence. So how do we enable them to leverage big data and machine learning tools? Industry, and specifically SAP, has the tools that are wizard-driven, point-and-click tools, yet very comprehensive to accomplish machine learning tasks like classification, regression, social media analysis, so on and so forth. So, to summarize, in industry, and SAP is part of that industry, that the machine learning, big data, optimized algorithm in products for citizen data scientists who are not very well versed with the machine learning algorithms, and the tools and technologies for the expert data scientists who know what they are trying to accomplish. And in this talk, for the next 35 minutes or so, I will be demonstrating the bottom two layers of this pyramid. Some of them through videos and some of them through the applications themselves. So some of the use cases, for example, this is the case in which we have an embedded machine learning algorithm accomplishing various tasks like cash flow, brand impact, resume matching, which is job matching, fraud management, so on and so forth. Each one of these models is specialized to accomplish this task that is listed in here. Like, for example, resume matching is a natural language processing tool which looks at the resume of a candidate, picks up the keywords, and matches that resume with the posted job description. And same thing, ticketing, and all of these have specialized machine learning algorithm, natural language processing tools catered specially for these tasks. Just to see how these applications actually work, I have a video demonstration for the brand impact. Brand impact simply automates the process which was used to be pretty manual, in that if a company XYZ pays some dollars to put their banner in a soccer or football stadium to be viewed on television, they would like to know how many or how much time that banner was displayed on television itself. Right? So that will account for if the money is well spent or not. So it was a very laborious, inaccurate message that a person has to go through frame by frame, look at the logo of a specific company to see if the logo or the banner is being displayed on television or not. So to automate that process, we have this brand impact application which analyzes the video in real time. Oh, not good. Let's see. That's why PowerPoint is not very good. So let's see. Okay, fine. So we can see that the videos as the application plays on, it is for various sports like hockey, sailing, skiing, wearable devices. In this case, this is for soccer. Like in here, we can select the brand which we want to follow within this video. And we can see as the video plays, we can see in real time how much each of these selected logos have been displayed, and the percentage also. And looking at the percentages, we can see compared with the competitors how these logos performed. And you can see in here SAP, it picked up automatically. Now the video is playing in the real time. We can see at the bottom Adidas, Etihad, Heineken. So it's an automated way of analyzing the video and converting the unstructured video information into a structured, actionable information. Now the customers know that if they spend this much amount of money and they were expecting 10 minutes of television time, did they get that 10 minutes of television time or not? So this is one example how SAP is enabling big data, machine learning, and artificial intelligence techniques to solve real world problems. Some of the areas in which we have applied this, what we call is our big data platform, HANA Data Management Suite. Those applications, they include image processing using Python. I will show one of these examples through PowerPoint. Machine learning is integration with the TensorFlow. TensorFlow is one of the main stream artificial intelligence or machine learning library, open source library for image processing. So this platform, SAP's platform, is open, integratable with the open source machine learning libraries like TensorFlow, Theano, and so on and so forth. Along with these integrations, it has its own highly sophisticated predictive analysis library, which let a practitioner develop algorithms, big data algorithms, without having to move data outside of a relational database to an application server. In this case, SAP's philosophy is to bring the application servers to the data, so that we need not to move the data back and forth between servers, thereby introducing some latency in machine learning algorithm execution, and so on and so forth. And not to mention duplication of the data in various data sources. Then we have text analytics engine built into this platform, and the other tools with the predictive analysis that are the citizen data scientist oriented tools. And also because just like I mentioned, this is an open platform. R is one of the better software packages to develop statistical algorithms. So this platform has an integration with R software package also. So some of the use cases and demos. The first, because we are living in the age of big data, and the most economical way of storing big volumes of unstructured data is the Hadoop environment. I'm sure most of you are familiar with what the Hadoop environment means. Hadoop is basically just like Google, Facebook's, Yahoo. Where do they store all of their big data? Economically, it is not feasible to store that data in our relational database management systems like Oracle's or any other IBM's and other things. There has to be an alternate. So way back in 1990s, Yahoo came up with an idea of using the cheap hardware with lots of redundancy to store large amounts of data. And they called that platform Hadoop. And now Hadoop is the mainstream platform for storing large amounts of data like Google's, Intel's, and you name it. All those data are stored in this environment. So because most of the businesses have the data stored in Hadoop, how do we leverage the information that is stored within Hadoop? SAP has provided an integration to Hadoop environment from our HANA data management suite, so that we can engage or we can join the enterprise data with the operational data that has been stored in Hadoop. This is one example in which case the structured data coming from the manufacturing process or molding process, structured data being temperature and pressure, which is measured after a sheet is molded into an object for a car, and the unstructured data, which will be of a large volume, are the infrared images. Infrared images, they capture the temperature variation in an image. So it is an unstructured information which captures hot, cold, and warm regions in the product that has been fabricated using this molding process. In order to generate any meaningful information, whether this produced object is good or bad, we need to combine both of these informations together. How do we combine pressure and temperature information with the image information? We need to process this image, convert, which is an unstructured information, just like a text data. We need to extract some meaningful structured information, which when we can join with the temperature and pressure, develop a predictive model to classify the object as good or bad. So how do we accomplish this one? This is the depiction: unstructured infrared image, structured temperature pressure data. We need to combine them together by processing this image data. And how do we process? We use Spark and Python machine learning libraries that are available within the Hadoop environment. So we process this information in the Hadoop environment itself, because images are stored in Hadoop. Each of the image subdivided into 100 subregions, and each of those subregions we look at the pixel densities, and wherever the temperature is higher, indicated by the red color, the pixel densities will be higher. So out of those higher pixel density regions, out of 100 subregions, we only keep the top 5 subregions, their raster, that is XY locations, and combine them together with the structured information of pressure and temperature and develop a predictive model. And the Python code would look something like this, which will run in the Hadoop environment and controlled by the SAP Data Management Suite. The second example, again, is the very interesting example, which I will supplement with the video, is how can we leverage the image data that is being produced by the businesses all over the place, like all these retailers, you name it, Facebooks are using for face recognition. Can this image data be used within the enterprise data to perform certain meaningful analysis? So this is a step in that direction. So just to explain this use case, a person uses this smartphone, takes the image of a clothing item, in this case a t-shirt. The t-shirt image is sent to the SAP data management suite. Because the image information has the geolocation information also, SAP has an embedded geolocation or geospatial engine that extract the information. That engine extract the geolocation information to be used subsequently for image display, location of the stores, so on and so forth. But the image itself is sent to a TensorFlow server to detect the brand, color, and sleeve type. Bring that information back into the enterprise data to merge it with the inventory data, that where this item is available, where it is not available, whether it's available online or not. And also using the other machine learning algorithms within SAP platform, generate the recommendation. Just like on Amazon web server, if you buy a t-shirt, there's a recommendation that the person who looked at this item also looked at this item or bought this item. So this platform has a built-in recommendation engine which will recommend the items associated with this t-shirt and color. So this is a solution to a real-world problem in which we have an image, we want to extract the information from that image and use that information to solve a business problem, in this case, to guide a customer to the right store, to the right location, or ask him to buy a different type of item. So I will just use one video real quick. So there's no audio to it, I will provide the audio. So this is a mobile phone app. So actually we can safely skip this one. I have already explained that we want to discover the information, optimize the business. So this is a smartphone application. Person takes a photograph of the clothing item with the logo of the clothing, short sleeve, color green. Now that image, after having been acquired, is being sent to the HANA or SAP data management suite. After having transferred to SAP platform, now went to TensorFlow, image recognition, object detection, data comes back to the SAP data management, merged with the marketing data and displayed on person's iPhone again. So top is the recognition, recommendation. People also looked at this one. And using the embedded geospatial engine and geo-encoding information, SAP platform can generate, using Google Maps API, the location of the nearest store as well. And here it is. So person clicks on one of the entries, item, location, what's the price, that's the enterprise data, and that's the whether online and so on and so forth. So the idea is that this is the real world solution to the problem. We generally, as a student, or we use each of these individual objects like image recognition, recommender systems, geospatial systems, Google Maps. But how do we monetize the information which is being created by each of those engines? That's one of the examples, that the retailers can use this information acquired from an image, various engines, whether in SAP platform or otherwise, working in harmony to solve a problem. The problem is, how do we get the sales for a given retail store up? and more. Any questions so far? Another very interesting example in this case is the utilization of the predictive analysis algorithms to perform a risk management situation, and that's a very common situation in the financial institutions. That is the Monte Carlo simulation. So SAP, of course, the Monte Carlo simulation, if we know the probabilities of various activities or various risk factors, the Monte Carlo simulation is nothing but more just by sampling those probability distributions over and over again and combining them together somehow to reach to a conclusion. For example, in this case, we know the temperature distribution, we know the rainfall temperature, humidity. What's the probability of rainfall in a given day? So we will just look at the probability distributions, sample them, and so on and so forth. So in this case, we had the risk factors for utility companies about their cash flow. All of these risk factors, they were converted into their respective probability distributions, and the Monte Carlo simulation was performed to come out with the risk factors and associated policy for the cash flow enablement. Various algorithms that are built into this SAP platform for various situations like classification, regression, time series, association, so on and so forth. These are highly optimized algorithms for the big data applications, along with the integration with R as well as TensorFlow for image processing. Another very interesting example, of course we can use the forecasting. I will highlight the text analytics engine, and then show one of the videos for its application, how the text analytics along with the other applications can be used to solve again the real world problems. Fortunately or not fortunately, I'm in the business of solving real world problems, so that's what I have to share, sir. Text analytics, on the face value, because we are human beings, to us it comes as a natural, right? Understanding text. But to make machines understand text and get the information out of it is very, very challenging. For example, if you look at this statement, you lost my documents, perfect. So perfect is a very positive, strong sentiment. But in this case, it is being used as a sarcasm. To understand, to make machine understand, it's quite a bit of challenging task. Same thing, I am happy, what do you do with this? I hate your services. So these are the challenges that the text analytics poses, that we as a human being, just like computer vision, comes to us as a natural. Most of us take it for granted. Same is the case with the understanding of the language. So how do we utilize the information that is contained in the text and use it for business purposes? SAP has its own highly sophisticated, just like any other vendor, their own text analysis engine. And how do we utilize that text analysis engine to solve some real world problems? I will show another video. So just the context for this one. What problem we are trying to solve in here? What we are trying to solve in here is, this is a real application that using our platform was implemented in one of the utilities companies in Holland. Generally speaking, whenever these utilities companies, they supply gas, electricity, water, all those kind of services. So generally what happens is, whenever there's no electricity in my home, generally what we do is we pick up the phone, call the utilities call center, tell them what this problem is. They ask my address if they do not know it already. Then they start to have to look what are the components of the utility, grid station, tower, whatever around my house, which might be contributing to the problem which I'm facing in the house, and then come back with me. Sometimes it will be very immediately. If they know the problem, they will let me know, oh, one of the pole is down, so we are working on it. If not, somebody needs to sit down, diagnose the problem, and get back to the customers. Sometimes it can take hours. So how do we automate that process? Near real time, this is the solution that we presented and was accepted by the customer and has been implemented. So now, rather than picking up a phone, of course, phone option is always there, but person can, by picking up the Facebook Messenger, can start typing a message, and the text analysis engine, using its sophisticated natural language processing algorithms, will try to understand what the question is. And without having a human being interfere or interpret the response of the text analysis engine, a machine learning chatbot will understand that question and provide the answer in real time and converse with the customer and try to find the solution to the problem in real time. And this is the video of a real-time conversation with the chatbot and dealing with the data. So we start. Facebook Messenger, rapid response. So the person types the message. Chatbot responds automatically. Not really, sorry to hear that. Again, just a simple conversation without any human interaction. So it is now asking for the address. So address will be understood by the text analysis engine, handed over to geospatial engine within SAP platform. That information will be used by the backend ERP system to find out what are the assets around that address, run a machine learning predictive algorithms to find out what's the probability of one of those assets being down. If no, then they will say, okay, something wrong at your house, not the asset. So we can see right here. So ask the address. So running this algorithm. So this is the initial diagnostic. Initial diagnostics mean somebody has not reported any problem around that address. So nothing wrong. So now they will say, okay, we run the detailed analysis. Now the geospatial engine will look at the assets around this address, whether they are subgrade, transformers, wired, something, and run machine learning predictive algorithms on all of the assets, and also show to the customer that, okay, we are looking at these assets in real time and running those algorithms to determine the probability of failure of any of these assets. Now we are using the graph engine also that is embedded within this SAP platform. So they say nothing wrong with it. Looks like there's a problem at your end because all the assets with the utilities seems to be working fine. This is again individually natural language processing, Google Maps API, text analysis. They might provide some information, but not a holistic information, holistic actionable information, like in this case. How much time? So I think this seems to be a good time to stop. We have about 10 minutes more, so more than happy to provide any feedback on the use cases that I have discussed, technology, or any in-journal machine learning related questions pertaining to the industry, more than happy to answer those questions. Sure.
Maybe you don't hear me.
No, no.
And is this real in the sense that, let's say, risk management of commodities or some other portfolios, they are not Monte Carlo. You don't have a probability distribution. You are perhaps hoping to have a alpha stable set of that data, and that's even too much to say.
Right.
So it seems like it is kind of trivial addressing the problem in this way. What kind of results you have? Because it's really a surprise that with this kind of approach you will get something that's close to reality or can be used to forecast any kind of situation in the stock market or something like that.
Right. So the answer to the question is, generally in businesses or in real world scenarios, we have to have a compromise between the time to generate an actionable information versus how accurate that information is. For example, if I run this same simulation maybe for a day, I will have more realistic solution, more realistic understanding of the business risk factors, if I have the accurate enough probability distributions. But if I have to get some information in next 10 minutes, this might be good enough an indicator to look into that direction. So you are absolutely correct. This is not the realistic indicator, but it is one of the solutions to start looking at the root cause analysis.
Okay, the point is the scale you are using to analyze the data. So your goal is, let's say, in a window of 10 minutes or 15 minutes.
Exactly. That's what I was hinting upon.
Okay,
Yes,
because the other issue is that your data is multifractal, and you will need multifractal analysis. Also.
Exactly. So that's what the situation is. Businesses always, we are concerned, or customers are concerned that the accuracy of, let's say, if a model gives me 81% accuracy versus some research algorithm which gives me 93 and takes about half a day to run, I will stick with 81 and do something of the situation what's coming to me.
I would say the brokers are the ones who can use this window time. The clients more or less have a day or something like that of interest, because unless you are very rich and you have your broker on your side, just right there, you are relying on a company and these kind of things.
And this was not the financial, it was a utilities company. They just wanted to simulate their cash flow. So they were not very overly concerned with the losing whole lots of money or trading that money. They just wanted to get the feeling how their cash flow is or what the risk factors and how they are impacting.
Okay. Thank you very much.
Thank you.
This HANA SAP software is possible to be installed in a facility in the university to try to test or to use for research?
Yes, you can. And because if you search the Google, there's a, just like if you're familiar with Microsoft Visual Express editions. So HANA has its Express and Developers Edition with full-fledged predictive analysis library embedded in it. You can download and use it for 60 days for free without any problem for research purposes. And of course, if the problem is more complex to understand, I think we can have our SAP representative come and talk to you. But I think if for experimentation purposes, just download the HANA Express edition. It's a virtual machine-based resource, full-fledged, ready to go.
What are the features that these demos have on the HANA DB management that doesn't have the HANA Expression Edition? Are there any?
Yes, some of it, because it depends which kind of, how much memory you have. Because the Express Edition, if you have, let's say, 32 gig of RAM in your laptop, then you can have more comprehensive with some more application development factors in it. Like as for the predictive analysis, both developers as well as Express Edition has also. Text analysis engine is included in both of them. Graph, etc., geospatial, they are not included. They were thinking of including, but I'm not sure. But text analysis as well as the predictive algorithm that I showed, they are included. And you can have the R integration with that also. It's a full-fledged simulation environment. So.
Do you have in mind any use case that has been implemented in Mexico?
I think that we have a number of customers, like for commercial side, like FAMSAs, ORCAs, and all the things. We have implemented all of for sales forecasting, demand forecasting, specifically for the educational institute. We have a very good relationship with Tech de Monterrey in Monterrey, and we implemented to suggest them the portfolio optimization strategies based on the same platform, based on the interest rate, various macroeconomic factors, and so on and so forth. So we were engaged with them also in Mexico.
Hello. I understand you have these applications running on real cases, on real companies.
Mm-hmm.
And I understand this is in the Netherlands, or no? Is this in the Netherlands? Is this application?
Yes, this is in Netherlands. That's because SAP is a global company, so yes.
How do you manage errors? I mean, how do you manage? I suppose you don't have 100% precision algorithms on these
Right.
things. For instance, sarcasm in these kind of things, or big errors in the example you showed us about the T-shirt application. How do you manage those kind of errors?
As far as the management of the errors, that varies from situation to situation. Let's say if we are dealing with the supply forecast or demand forecast, the error is how much the percentage deviation from the forecast we are having. For the image recognition, it will be whether I'm able to detect the logo correctly or not. Mm-hmm. So how do we generally approach is we sit down with the customer and ask them that what is their major concern as far as the business operations are concerned. And then what is the deviation they feel. For example, they think they are using Excel and they find out that at the end of the day, the demand they place is, let's say, 1,000 items more or 1,000 items less than actual demand. Then we know that we need to look at the time series error reduction. If they say they are looking at the recommendation for various products and the recommendation for T-shirt comes out to be tie, that's the error. So we try to rectify that one using the recommender system. So to answer the question, summarize, it depends from situation to situation, and we look at the customer suggestions or pain points and then map that one into the scientific algorithm to the accuracy measure and try to reduce it.
Agradecemos la plática tan interesante que nos brinda el doctor Farroq Azam. Brindémosle un aplauso.
Thank you so very much.
Doctor, we want to deliver a diploma, also for Matthias.
Okay. Thank you so very much. Thank you.